Hello, this is part 2 of the same chapter that we were dealing with water, its uses, and management. We ended with that the amount of precipitation you get is dependent on global ocean currents. This is kind of a picture of that. Again, like I said, I will be posting another video for just going over all the different ocean currents, what they mean, like what are the different climate patterns and all of that stuff. Okay, now oopsie daisy. Now we come to frozen water. About 2.4% of the world's water is classified fresh, and most of them are in glaciers, ice caps, snowfields, all that wonderful stuff. Now, here is most of it. You can read it. As you can see, this portion here is stuff that I have added, and it is very important, especially these dates. So the glaciers have been melting have been receding, becoming smaller and smaller and smaller since 1850. It kind of coincides with the industrial age, like the beginning of the industrial age, around that time. And then from the 1970s, it has actually accelerated. So it started in 1850 and kind of accelerated in 1970. Now, one of the biggest myths that you're going to hear is that glaciers are actually growing. This is the one that's, oops, come on, Tinkle, get down. The one that you're going to hear a lot about is reports are coming from all over the world that for the first time in over 250 years, glaciers in Canada, Alaska, New Zealand, Greenland, and now in Norway are growing. Now, this is very interestingly cherry-picked information. So the way glaciers are formed, it depends a lot on both temperature as well as the amount of precipitation. So when we're talking about glaciers shrinking worldwide, we're looking at a long-term trend, and that is shrinking, but that is not a year-to-year description of what's happening. This report here is based more on a year-to-year trend. So Norway in the past couple of years has actually seen an increase in the size of the glaciers, but that's more indicative of the temperature change and the precipitation change, which is also a part of climate change. That under no circumstance that day-to-day change or the year-to-year change in size typically does not indicate a trend. For that, you have to you have to go historically and look. It has to be a larger picture. Not what's happening on a day-to-day basis. Like if I'm driving my car every day in the freeway and it gives me 37 miles to a gallon, doesn't mean that my car everywhere will give me 37 miles to a gallon. My car does. Now, the part that we're going to spend a lot of time on here is groundwater. About 1% of the Earth's water is in groundwater. It is, I need you to remember, oops, oh, I am a klutz today. I need you to remember this word, potable water. That is drinking water. You will see this word come up many times on your tests and stuff like that. Remember, this water is one of the most important sources of irrigation as well as industry. It is also a water that is kind of out of sight. Because it's out of sight, we tend to not care as much about its pollution as we would care about a river or a lake that's where you can actually see it. You don't see this groundwater, so it's like out of sight, out of mind. However, we have talked about this in the past in class. Once this water is actually contaminated, the amount of time it takes for that purification is pretty much, the estimates are anywhere from 3,000 to 20,000 years. There are other problems as we go along. I'll talk about other problems that they have. So instead of going through all of these, I'm just going to go to the next slide where there is a picture and then you can kind of see it. So the groundwater there's an infiltration zone obviously where the water kind of infiltrates. This zone is usually made up of loose rock, clay, and silt, sand, and that kind of particles. Then you have, it's also the zone of aeration. Everything is not tightly packed, so there's a lot of air in there. Please also remember that this will be a part of your chapter 9, that this zone of aeration is very, very important because it also contains almost every type of aerobic bacteria that's going to later on impact in nitrogen fixation and all of that stuff. So please remember that. Then you have the zone of saturation that is completely saturated with water. The top portion of that is the water table. Depending on drought, for example, in California, they go deeper and deeper and deeper to dig a well. Most of the times, if you were to dig a well in, let's say, where Max lives, which is like Danbury, you would basically go up to that area. You would not be going all the way down here. But where I live in California, we would have to go further and further down because our water table is receding. So a couple of things to remember here. The zone of aeration is very important. This is where air, excuse me. This is where the air percolates through, the water percolates through. It is a combination of sand, silt, and loose rock. It contains most of your aerobic bacteria, which not only helps these plants grow because it does nitrogen fixation. How does water get in there? There's like rain. There is obviously precipitation, evaporation from other sources. There's runoff. So if you had contaminated water runoff and contaminated water percolating through the soil, you are essentially eventually contaminating the groundwater. Aquifers are porous layers. Shh. Those are my dogs. Again, reach. So the next thing is aquifers, which is a porous layer of sand, gravel, rock lying underneath the water table. So it's, if you go back down and look at the other picture, it's going to be underneath there. Okay. So the artisan ones are pressurized aquifers. You don't really have to pump water out. It intersects and it, like, think of it as being a U-tube from basic physics classes and U-tube, and the pressure inside is equalized to the pressure outside. But if one side is clogged, or if you kind of close one end of it, then the pressure rises on the other end. I don't know if I can draw it out here. I'm gonna try. A pen, right? Think of it as like I can't do it there. Maybe I can do it here. Like that, like a U-tube. Ooh. That's a horrible tube. But so usually, the water level is going to be, let's say the water level is here, because of that's where the external pressure and internal pressures are equal. So that's where it lies. But if this part for some reason is closed, then the water is going to rise up. Okay, it's going to rise up that way. That would make it an artisan or a pressurized aquifer, where the water comes out by itself. Recharge zones, this is the most important thing. Places where the aquifer water infiltrates into the aquifer, where water is coming from outside sources, be it precipitation, be it runoff, close by water body, floods, I don't care what you call it, but it recharges it. Now the recharge rate is very, very, very low. If you go back, let's look at this. So most of the water is right here, depending on the amount of agriculture you're doing, depending on the amount of water you're pulling out of the water table. That way, a lot of it is going to be used up. So that's going to cause this this groundwater recharge to be very, very low. For example, in California, we have used up to 60% of all the water in our groundwater. That means there's less water going in this direction and more water going in that direction. And that's one of the reasons why recharge is so slow. As you can see, it can find aquifer, water coming in. Now, one of the things, so these are active wells. Now, depending on how much water you have in your area, how much recharge there's, these active wells can in the case of California, we're actually going all the way down there. So if this was a well in California, we are actually drawing water out here. Okay. This is one of the things that I got from this is a picture I got from the USGS website, and you can see here, these are basic. This is coastal ranges in Sierra Nevada. This is California. You see the Central Valley, California, and you will notice where there is actually our pumping lakes are almost reaching the bottom of our aquifer. Now there is another problem. We are a coastal area, so there's marine deposits and there's actually salt water coming in. So there is, the further down we go and the further porous we make this layer, we have a problem of having marine water, salt water enter into our aquifer. And this has happened in the past once. That's actually made California's soil very, very alkaline. Okay, so the next part we're going to talk about here is rivers and streams. Precipitation that does not evaporate. If something doesn't evaporate, does not infiltrate into the ground, does not leave to go, meet the ocean, it's going to go into a lake, a river. It is one of the bigger sources of fresh water or potable water that we have. Do I expect you to know these things? No, but they tend to ask simple questions like on the test. The only question you might get is the Amazon River as being the having the largest annual discharge rate. That is the only question you might actually get. You might get a few questions about Yahtzee just because Yanks, whatever that thing is, because of the fact that it floods so frequently, but that's about it. Lakes and ponds. Now, most of these, we have a lot of, I think Florida and California are two places that are very, very famous for their man-made lakes. Lakes and ponds also happen to be the most polluted that we have at present. I think the most polluted lake in the country is in the city of Syracuse. I'm drawing a blank on its name, but it starts with an O. So, and depending on what kind of outlets they have to these lakes, and depending on what kind of, where the water drains and where the water comes in, the contamination levels change. Mostly, I think nowadays what people are, when you build a sustainable housing development anywhere, they kind of have lakes in them. Mostly support local plant life. It also acts as a catchment basin for rains. California has it because we like water sports, even if it's on the lake. And it is a drain on the water system in California because most of the lakes are manually filled with water. You have to fill the lake with water. Lake Castaic, which is in Southern California, it's a huge lake, Lake Castaic. You will have, I have seen questions on this. So, Castaic. Oh, I'm gonna run out of time. Which is actually a drain on the resources of water because the lake has to be filled. I am going to stop at wetlands because I'm running out of time on this section, but we'll get